Hello, my name is Fernando, and this is my partner,
Kenneth. We're gonna find area enclosed by the ellipse. So
our problem is number 3, which is x squared divided by 16 plus y squared divided by 25 equals 1.
for this problem, we need to solve let y on the left side so that y square equal over 25 equal 1 minus x square over 16, and we make a common denominator for right side so that y square over 25 equal 16 over 16 minus x squared over 16. And then you can multiply 25 to the other side. So this is cancel. So y squared equals so this can be 16 minus x squared and 25.
Factor out
the
1 over 16.
1 over 16. So y squared equal 25 over 16 and 16 minus x squared.
Perfect. Next slide.
And we can square root the right side to get rid of the left side square. So here we go. Square both sides, and this one's gone. So y equal 25 over 16 square root and multiply square root and 16 minus x squared. And as you see, you can take out, you can solve this, simplify, so that y equal 5 over 4 multiply 16 minus x squared.
So now, with this equation, y equals 5/4 times the square root of 16 minus x squared, we can see that this only gives us a portion of the ellipse. What I mean by the portion is that we have an ellipse, and we know that some major points are here at 0, 0. We also know that there's intersecting points at x minus 4 and x equals 4, as well as y equals 5 and y equals negative 5. Now with the equation above, this only gives us the shaded in area of the ellipse. So now we are trying to find the entire area of the circle, which would mean this side here, this side, and this side. Now how do we do that? Well, we go ahead and integrate this equation here and multiply by 4. Why 4? Because there's 1, 2, 3, and 4 areas to the triangle. So now, for the total area of the ellipse, we have 4 times the shaded area. The shaded area was the previous equation. So we have 4 times the integral from 0 to 4. It's 0 to 4 because, like I mentioned, we're only going to find the first shaded area, but we're multiplying it by 4 because it's 4 sides to it. So we have 4 times the integral from 0 to 4 of 5 over 2, the square root of 16 minus x squared dx. So, how do we derive this? Well, one thing's for sure, we cannot use u substitution because it just becomes very complicated. As you can see, we'll do a little side note. If we let u equal, say, what's inside the radical, which is 16 minus x squared, we see that du gives us 2x dx, which negative 2x dx is nowhere in our original equation, so we can't really substitute that. So u substitution is out of the question here. So now we go ahead and base our solution on trigonometric substitution. We know that when we have, here's a little side note. We know that when we have the radical of a squared minus x squared, we can substitute it with x equals a sine theta, which, for reference, this is also an identity, which is 1 sine squared theta cosine squared theta. So now, knowing this, that we could go ahead and substitute it for a sine theta, we could go ahead and this. So we have 4 integral of 0 to 4 4 times 16 minus x squared dx. So we first cancel out the 4's because 5 over 4 is a constant as well. So when we have constant, we could go ahead and pull it out. So we have 5. So the integral between 0 and 4 is 16 minus x squared dx. Now, if you already know that you could go ahead and substitute it with a sine theta, then that's fine. But if you don't, here's the explanation on how to do it. We know that we have to substitute it with sine. So let's go ahead and draw out the triangle. So we have a right triangle. Here's our theta. And we know that sine theta is equal to opposite over hypotenuse. We also know that an ellipse equation is x squared a squared plus y squared b squared. So initially our a squared was 16, so our a would be 4.
Yeah, 1.28.
So we know that x equals a sine theta, which is x equals 4 sine theta. And using our basic trigonometric ideology, we have sine theta equals x divided by 4, which is our opposite, which is our x, opposite of the angle. Then we have 4 and our hypotenuse. Now we use basic a squared plus b squared equals c squared to solve for this here. By using a squared plus b squared equals c squared, it would give us what's originally in our function, which is 16 minus x squared. Now, knowing this, we could go ahead and substitute our limits. We know that when x is equal to 0, theta will be 0. And when x is equal to 4, we know that theta will be pi divided by 2. So now we could go ahead and take advantage of what we know, which is 4 sine theta equals x. And when we find the derivative, we know that it's 4 cosine theta d theta equals dx. And we know that cosine theta is equal to 16 minus x divided by the square root of 16 minus x squared divided by 4, because we know that cosine is equal to adjacent over hypotenuse. So with this, we have 4 cosine theta equals what's inside our integral, which we could go ahead and substitute it. So now, by substituting the integral, we have, and also because of our limits that we change, we have 5 from pi over 2, because we said that when it's equal to 4, we have pi over 2 to 0 of 4 cosine theta times 4 cosine theta d theta. Multiplying the 4 times 4 gives us 16 times 5, which will give us 80. The integral between 0 and pi over 2 is cosine square theta d theta. And we could also use the half angle identities to go ahead and change the cosine squared theta to 1 plus cosine 2 theta all over 2. So we know that 1/2 is a constant, the 1 and the half. So the 1 and a half is a constant. So we could pull that out, and we'll have 80 divided by 2, integral between 0 and pi over 2 of 1 plus cosine 2 theta d theta.
As we know, we can make a separate integration. So 80 over 2.
Right, but I went back and relearned it, and the way I relearned it was because Linda is such a nice snake, right?
D theta plus integral of 0 to pi over 2 cosine 2 square d theta. So we make a 2 separate integration, and you got which is integrate. So 80 over 2. Then we integrate and we get the data of 0 to pi over 2 plus 1/2 of sine to theta and 0 to pi over 2. So we can solve this. So pi over 2 minus 0 as an, so we can rewrite as 80 over 2. So pi over 2.
Since we don't have a graph, we have to guesstimate.
And I can rewrite this as half sine square, which is pi over 2, minus at the bottom, which is 0, so pi over half sine square of 0. And then, so when you do the calculation of that, this, we get the 0, and when you do the calculation of this, we get the 0 too. So 0 minus 0 does give nothing. So we left with 80 over 2, pi over 2, and 0, which is 62.83. So that is your answer.
And we could also go ahead and check the area of the ellipse by its simple equation, which is a times b times pi. This will give you the complete area of the ellipse. And if you were to calculate 4 times 5, if you recall, x squared 16 plus y squared equals 25. Sorry about that. 25 equals 1. These here are our a squared, and this one here is our b squared. So when you multiply 4 times 5 times pi, it should also give you 62.83, which they match.